All right, everyone, this is section 3.1, lines and angles. For your do now, they just want you to write T for true or F for false next to each statement. Feel free to pause the video now, attempt it on your own, and then check your answers by resuming the video when you are ready. You can name a plane by a capital such as A. Well, that is true. A plane contains a finite number of lines. That one's false. Infinite number of lines. 2 points lying on the same plane are coplanar. That's true. And if two distinct planes intersect, then they intersect at exactly one line. That is also true. All of our vocabulary terms, we're going to use this diagram to aid us. Okay, our first vocabulary term is parallel lines. Those are lines that lie in the same plane, but they never intersect. Okay, our examples, our line AE is parallel. Notice the symbol for parallel looks like a sideways equal sign. So line AE is parallel to line BF, and let's take a look there. AE is right here, and BF is right here. So these are parallel lines to each other. Okay, they are never going to cross. All right, if we go back to skew lines, are lines that are non-coplanar, not in the same plane. They are not parallel, and they do not intersect. For example, line AB and line CG. So take a look. Line AB runs this way, and CG is in the back of the figure and runs up and down. These two lines will never intersect. They are not on the same plane, and they are certainly not parallel. Parallel planes are planes that do not intersect. For example, plane ABCD and plane EFGH. Well, ABCD is the top, and EFGH is on the bottom. These two planes are never going to intersect each other, and they are parallel. The top of the square and the bottom of the square. Cube, I should say. Okay. Identifying non-intersecting lines and planes. Which segments are parallel to AB? AB is right here. And what would be parallel to AB? Sorry about that, guys. Okay. So we have line EF, DC, and HG. We'll take a look. Here's EF, certainly parallel. DC, parallel. And HG, parallel. All four of these lines run in the same direction, and they will never intersect each other. Which segments are skew to CD? So CD, if they're going to be skew, that means they cannot be in the same plane. They cannot be parallel. Okay, so what do we have? We have BF, AE, EH, and FG. Well, let's take a look. BF, certainly skew. AE, also skew. EH is down this way, definitely skew. And FG. Okay, and if we go back to our definition, all of those red lines are skew to the blue line, which means they are non-coplanar, not parallel, and do not intersect. What are two pairs of parallel planes? Well, the first one I have is plane ABCD and plane EFGH. Well, here's ABCD. It's the top of your figure. EFGH is the bottom of your figure. Those are certainly parallel planes. Okay, my second example, but there are others. I put DCG, which is the side or the right side, to ABF, which is your left side. Okay, if you wanted to choose a different pair, you could have chose the front and the back. You could have chose plane ADHE and BCGF. Okay, those are also parallel planes. And what are two segments parallel to plane BCGF? Well, here's B, C, G, and F. We need lines that are parallel to those lines. So we have AD and DH. AD is parallel to this line here, BC, and DH on the right-hand side is parallel to CG. Okay, more definitions. We have transversals. Your transversal is a line that intersects two coplanar lines. And if you notice, our transversal in this image here is labeled T. And you can see this blue line crosses over line L and line M. So when we have transversals, there's such a thing as exterior angles and interior angles. Our interior angles are inside of the two coplanar lines, line L and line M. Notice it's got this kind of light yellowish color on the inside. Those four angles are angle 3, angle 4, angle 5, and angle 6. Your exterior angles, notice, are either on the top or the bottom outside of line L and line M, and that would be angles 1, 2, 7, and 8. So you have interior angles and exterior angles. That's going to help us in a second. Okay, so we have the figure here. We have our transversal labeled T, we have line L and line M, and we have all of our angles labeled. Same side interior angles are interior angles that lie on the same side of the transversal. Remember, interior would be inside line L and line M. And now we're going to look at same side, meaning that they're on the same side of the blue line, the transversal. So we have two options. I could choose 3 and 6, or we could choose angle 4 and angle 5. Those are considered same side interior angles. Now, alternate interior. Again, we're dealing with our interior angles inside L and M, and here's my transversal T. Alternate interior means I'm going to choose angle 3, and instead of looking at the same side, I'm going to go to the alternate side, which would be angle 5. Or we could choose angle 4 and angle 6. Those are alternate interiors. Okay. Moving on, we have alternate exterior angles. Well, now we're going to look at the exterior, which is outside of line L and line M. And if I have alternate exteriors, I could choose angle 7, and on the alternate side of the transversal would be angle 2. Okay, so first would be angle 7 and angle 2. And our other option would have been angle 1 with angle 8. Corresponding angles lie on the same side of the transversal in corresponding positions. Okay, so this one's a bit unique. All we need to do is look at the transversal, and the way I would envision this is you have two groupings of four angles, okay? If I was to look at angle 1, that is in the same spot as angle 5, okay? If I looked at angle 2, that's in the same spot as angle 6. If I looked at angle 4, that's in the same spot as angle 7, and angle 3 is in the same spot as angle 8. Okay, so identifying angle pairs. It says, which is a pair of alternate interior angles. So I'm going to look at the interior in between lines M and N, and they need to be on the opposite sides of the transversal. So that would be angle 2 and angle 6, or angle 7 and angle 3. Well, the only choice between those two that I see is angle 2 and angle 6. Now they ask for 3 pairs of corresponding angles. So those are the ones we just reviewed. So angle 1 is in the same position as angle 3. Angle 8 is in the same position as angle 6. And angle 2 is in the same position as angle 4. And if you want to give the last one, we could say 7 and 5. Okay, classifying angle pairs. The photo below, well, it's above in my photo above, shows the Royal Ontario Museum in Toronto, Canada. Are angles 2 and angle 4 alternate interior angles, same side interior angles, corresponding angles, or alternate exterior angles? Well, here's angle 2, here's angle 4, and here's my transversal. They are on different sides of the transversal, which means they are not same side interior, and they are also not corresponding angles. So it comes down to alternate interior or alternate exterior. If you notice, these two angles fall on the inside, which would make them alternate interior angles. Okay. Here's your exit slip. It says which segments are parallel to line AD. Well, tell me which lines would be parallel to AD. All right. Next, they would want you to explain why FE and CD are not skew lines. Why are these not skew? What is a pair of parallel planes? And what are 2 segments parallel to plane DCGH? So feel free to pause, try these on your own, and I'll check your answers when you submit. Which segments are parallel to AD? Well, AD is going to be parallel to BC, FG, and EH. Next, they want you to explain why FE and CD are not skew. Well, FE and CD are not skew. Well, for something to be skew, they have to be non-coplanar, which these two are. They fall on 2 separate planes. Okay, but they also have to be not parallel, and these 2 lines are parallel. So we're going to write FE is parallel to CD. What is a pair of parallel planes? Well, we could take the top of our box, and we could take the bottom of our box, and those would be parallel. So we're going to say plane ABCD is parallel to plane EFGH. And what are 2 segments parallel to plane DCGH? Well, DCGH is here. And what would be parallel to DCGH? Well, we could use AB, and we could use EF. All right, thanks for watching. Don't forget to submit your work.